All right, our next one is number 17. It is an indefinite still. There are no bounds, so we will have a plus c of some sort. Bless you. And we're going to go ahead and just antiderive this. First of all, the way when we were doing derivatives, as far as it's all about the rewrite, there is a lot of that going on right here as well. Okay? Looking at this problem, what comes to mind as far as manipulation?
1 minus cos 2x.
Or cosine squared, right?
Yes, cosine squared. We have sine.
Yep. So the most important one that I'll say for you to memorize is cosine squared plus sine squared. Any one is equal to what? 1. The other two is cosine of 2x and sine of 2x. These are identities that you're going to use, continue to use in manipulations of the first one for the rest of the year. So 2 sine cosine, and this is cosine squared minus sine squared. Okay, so as far as that goes, these are almost similar, only one is addition and one is subtraction. We see that we have 1 minus cosine. That would be like manipulating this one that you have memorized, and sure enough, you could rewrite it as cosine of x over sine squared dx. Now there was a test that we did take when we were taking derivatives and whatnot, dealing with trigonometric functions, where it was about the rewrite. So I think actually this might have been the limits test. So if I broke up sine squared into 2 sines, okay, we know that there's an understood 1 here. Whoops. Can someone tell me what, oh my gosh. What that would be? Cotangent. Okay? So this is cotangent. A piece of it is cotangent, right? And, oops, let me write this in dark blue. What would this other piece equal? Cosecant. Cosecant. Now you tell me, have I taken the derivative, yes or no? No. Oh, sorry, my bad. The antiderivative. No, not yet. What if we, so let's say, what would we have to take the derivative of in order to get, as an answer, this? Do you remember from the trigonometric, those 6 that you memorized? What did we take the derivative of that would get us cotangent cosecant? Negative cosecant. It would have to be a negative cosecant because look, from memory, and this is where the negative mistakes come into play, if I take the derivative, I get negative cosecant cotangent. Okay, we know that this is very close to the same, it's only off by a negative. So if I divide both by -1, I could say the integral of a positive cotangent cosecant would equal this negative cosecant. So we get negative cosecant of x plus c, which is the same as the answer, only they put the c first. Okay, so you will see a lot of those very, very soon, even more so.